Is Vernon Neal Reed again here with AI Infrastructure Media and articles worth reading. This is another one that I picked up. It's from back in June of this year, but this is on SciencesPo. What was interesting about this is, and I have not read it yet, but if you look at what it says here, this essay was recognized as runner-up in the 2025 Spring Semester Cheers Essay Competition. The competition, coordinated in partnership with the European Investment Bank, focused on the topic competitiveness in a low-carbon economy, the role of innovation and green technologies in maintaining the competitive advantage. So this was recognized as the runner-up, and I thought, okay, cool. Let us read through this. The title, as you can see here, is "The Heat is On and How to Reclaim It: Industrial Symbiosis for Data Centers." Now, I believe this, in looking at the article, this article is possibly going to take about, I don't know, 9 to 12 minutes. So I'll let you know that. But I believe, again, that it's worth reading. And so that's why I am sharing it with you. All right. So just a couple of things here that I want to make sure so that you can see even to the bottom, but we're going to go all the way back up and we will start again. I hope you guys are having a good evening, or you had a good weekend. Sunday night, 10:05, 10:08 right now. All right, so let's get our reading on. Intro. The rapid expansion of the digital economy has made data centers critical infrastructure, yet their energy intensity poses significant challenges in a low-carbon transition. As environmental regulations tighten, industries that are increasingly reliant on data centers must innovate to remain competitive without shifting operations to jurisdictions with weaker climate policies. Advancements in cooling systems technologies and methodologies are central to reducing emissions while supporting performance and cost efficiencies. This essay will focus particularly on the potential for Europe to apply existing industrial symbiotic models to growing data center operation investments. Now, I know this is not based on US, but bottom line, best practices are best practices, or findings are findings. And so at least seeing what this essay says and the research behind it could be beneficial. And it might be something that, could be modeled elsewhere as well. But okay, let's go from there. Industrial symbiosis solutions. Industrial symbiosis is defined as a collaborative relationship between, let me move this around, I'm sorry, between distinct entities such as companies and factories, where they exchange resources like materials, energy, water, and byproducts. At its core, the principle of industrial symbiosis involves the waste or byproducts from one industrial process becoming raw materials or inputs for another, effectively creating a closed-loop system of resource utilization. For maintaining competitiveness, it can generate new revenue streams from the sale or utilization of byproducts that were previously considered waste. The collaborative nature of these relationships may also open up new business opportunities and strengthen the environment profiles of the participating organizations. In some cases, symbiosis initiatives can lead to the creation of job opportunities and improvements in working conditions through the sharing of infrastructure. For achieving a low-carbon economy, industrial symbiosis inherently promotes increased energy efficiency and resource conservation through the optimized utilization of available materials and energy flows. It can lead to reduced raw materials and waste disposal costs for participating companies by finding alternative uses for what would otherwise be discarded. By diverting waste and promoting resource reuse, industrial symbiosis effectively contributes to reduce carbon emissions and a lower environmental impact. Industrial symbiosis enables European industries to repurpose waste into valuable resources in creative ways. For example, power plants have supplied waste heat for district heating systems, providing energy to local communities. This indicates strong potential for European projects to scale these solutions for the evolving landscape for data center cooling, particularly given increasing heat outputs. Data center cooling and industry trends. Data center cooling is a process of removing heat generated by IT equipment to maintain optimal operating temperatures and ensure reliability. Traditional air-cooled methods, long the mainstay of data center thermal management, are increasingly proving inadequate to handle the escalating heat loads generated by modern high-density computing environments, especially those supporting AI and HPC workloads. Consequently, liquid cooling is rapidly emerging as a crucial solution for achieving both sustainability and enhanced operational efficiency, with projections indicating it will surpass air cooling as the primary cooling method before the end of the current decade. And you can see a diagram of what they're talking about there. Traditional air cooling on the left and liquid cooling on the right. The market for data center liquid cooling is experiencing substantial growth, estimated at 5.2 billion. These are euro dollars in 2024 and forecasted to reach 44.2 billion by 2034, demonstrating a robust CAGR of 23.96%. Recent surveys indicate that 22% of data centers are currently utilizing direct liquid cooling or DLC technologies, with a further 61% actively considering its adoption in the future. This growing interest is further amplified by the anticipated impact of new hardware platforms like NVIDIA's Blackwell, which is expected to drive the adoption rate of liquid cooling solutions from approximately 10% in 2024 to over 20% in 2025. The diagram here shows, or the figure, a graph that shows liquid cooling versus air cooling forecast between 2021 and 2028. All right. The increase in both the regulation requirements and market availability of more sophisticated cooling systems will continue to directly affect the amount of heat byproduct. This escalating heat output presents both a challenge and an opportunity to maintain competitiveness in the low carbon economy. The potential of utilizing this waste heat as a resource aligns with the principles of industrial symbiosis. Symbiotic model for data centers heat outputs. Data centers generate substantial quantities of low-grade waste heat, typically in the range of 25 to 35 degrees Celsius, from traditional air cooling methods or systems. Liquid cooling technologies can potentially yield even higher waste heat temperatures, often between 50 to 60 degrees Celsius. This thermal byproduct, often simply vented into the atmosphere, presents a significant opportunity for capture and reuse in various applications. Thermal byproducts can be utilized for heating nearby buildings, including residential, commercial, and industrial facilities, through the establishment of district heating networks. For example, I got it highlighted here, Microsoft's data centers in Finland are designed to supply their waste heat to the cities of Espoo and, I cannot pronounce that name, Kuani, for district heating purposes. Similarly, Facebook's data center in Odense, Denmark, is utilizing its waste heat to warm thousands of homes. Wow, this is interesting. A data park in Stockholm has set an ambitious goal of using waste heat from the data centers to meet 10% of the city's heating needs by the year 2035. Octopus Energy has made a significant investment in Deep Green's innovative data center heat reuse technology, which aim to roll out systems for public swimming pools across the UK. Interesting, man. For agriculture and aquaculture purposes, recovered heat can support greenhouses, enabling crop cultivation and fish farming. The RISE Research Institute of Sweden has established a partnership to reuse waste heat generated by data centers to heat greenhouses where containing greens grow lettuce for local restaurants. Green Mountain in Norway has partnered with lobster farms to utilize the heated water discharge from its data center for a novel load land-based lobster farming operation. On the right, the illustration shows a lobster production facility. Is on the so the illustration on the left and the actual lobster production facility is on the right. Advantages and risks. Adopting industrial symbiosis principles offers significant economic benefits for European firms. Waste heat recovery can lead to revenue generation through the sale of thermal energy. Engaging in resource exchange can lower operational costs and enhance a data center's reputation, attracting environmentally conscious clients and investors. Furthermore, transitioning to sustainable data centers may make companies eligible for additional green financing options and government incentives for which they otherwise wouldn't qualify. From an environmental perspective, waste heat recovery leads to a reduction in the carbon footprint of data center operations. By participating in resource exchange, data centers contribute to a circular economy, minimizing waste. However, the implementation of data center waste heat reuse is not without its challenges. Effectively matching the supply of heat with the demand from potential users can be complex, as both can fluctuate based on seasonal variations and operational schedules. The costs associated with building the necessary infrastructure, and that's what I was thinking about. The costs associated with building the necessary infrastructure to distribute the heat, especially over longer distances, can also be significant. In some cases, the temperature of the waste heat generated by the data centers might be lower than what is required by the end user, necessitating the use of heat pumps to boost the temperatures, which adds to the complexity and energy consumption of the systems. Got a call here. So almost like you're going to be moving this heat, but by the time it gets to where it's going, the temperature drops. So there has to be some way to boost it. It's almost like electricity and having to kind of repeat repeat the signal. Data center operators might also have reliability concerns about integrating their operations with external heat users and may be hesitant to invest in the necessary heat recovery equipment. Conclusion and areas for further study. Industrial symbiosis, particularly through waste heat recovery, enhances digitization, sustainability, and creates new value streams for data centers and their communities. Benefits include reduced operational costs, lower carbon footprints, and improved reputations. Implementing heat reuse initiatives can bolster competitiveness by providing an additional revenue stream and reducing environmental impact, making facilities more attractive to customers and stakeholders. Furthermore, in the business-to-business landscape, sustainability is rapidly becoming a key differentiator, especially when data centers seek partnerships with large tech companies that have established ambitious environmental sustainability targets of their own. Government incentives specifically designed to support green data center development can help to offset the initial capital investment required for advanced cooling technologies and industrial symbiosis projects, making them more economically feasible. Bottom line, taxpayers are paying for it. But again, if it's serving everyone, it could be useful. It could be very useful. At the EU level, the Energy Efficiency Directive and European Cluster Collaboration Platform, ECCP, they're creating a policy landscape that encourages these practices. Furthermore, industry-led efforts like the Climate Neutral Data Center Pact can contribute to driving sustainable practices within the sector. Increased dialogue between governments, researchers, IT manufacturers, and firms with increasing data demand should explore the standardization of the equipment in order to meet interoperability needs across the continent. Finally, this essay did not explore the potential for industrial symbiosis on the major input for data cooling. That is water. While DLC, immersion cooling, and AI monitoring promises to significantly reduce the consumption of water, it remains a pressing concern. The reason for omitting an analysis on these systems is due to the fact that the specific application of treated wastewater as a coolant in DLC systems appear to be in a nascent stage. And I want to make sure that you're able to see this, but it's not scrolling up. Give me 1 second. How do I do this? All right, I'm just going to read the rest. And then, yeah, I'm just going to go ahead and read the rest out loud. It's not going to show up on the screen. And go from there. Where were we? The reason for omitting an analysis on these systems is due to the fact that the specific applications of treated wastewater as a coolant in DLC systems appears to be in a nascent stage in the United States and Singapore, with no widely publicized examples in Europe. The stringent water quality requirements for DLC mean that the treatment of wastewater would need to be exceptionally thorough. However, as DLC adoption increases, it's highly probable that research and pilot projects exploring the feasibility of treated wastewater for DLC are underway or will emerge in the near future. Platforms like Water Reuse Europe Knowledge Exchange Day could potentially feature future discussions on the scalability of these projects in Europe. Additionally, European projects like Renutri Water are advancing water recycling technologies that might be relevant to delivering high quality water to data centers in the future. And that is the end of the essay. All right. So this is on SciencesPo. This essay was written by Seamas Porter. And again, this was part or it was recognized as a runner-up in the 2025 spring semester's Shares Essays competition. I thought it was very interesting. Obviously, there's still more to flesh out here and to see how something like this could actually work. But the fact that these are things that they're thinking about to ensure that data centers are being used as efficiently as possible, and that they're also thinking about sustainability and the environment. I think all of those are very good things to know. All right, that was it. My name is Vernon Neal Reed, and this is AI Infrastructure Media. And this was an article worth reading, and it was. Take care.